Hello. Today, I want to take you through an elegant geometry puzzle that beautifully showcases how tightly bound the properties of a circle really are. Let's visualize a semicircle resting on a horizontal diameter, AB, with a total length of 32 units. This means our radius is a clean 16. Now, let's place 2 points C and D on the arc above. We are given two specific structural conditions. First, E is the exact midpoint of the chord AD, and second, C is the midpoint of the arc running from B to D. To lock this system into a single, fixed position, we set the inscribed angle BAD to exactly 60 degrees. Our challenge is to find the precise length of the segment CE. At first glance, calculating a distance between a chord's midpoint and an arc's midpoint might seem like it requires a messy, drawn-out calculation. But if we break it down, the geometry unfolds incredibly cleanly. Because ADB is inscribed in a semicircle, it forms a perfect 90 degrees angle. Combining that with our given 60 degrees angle, triangle ABD becomes a standard 30 degrees, 60 degrees, 90 degrees right triangle. If we set the center of our semicircle at the origin of a coordinate plane, this angular relationship allows us to pinpoint the exact coordinates of every single vertex. By applying standard trigonometric ratios with our radius of 16, we find that point D rests at -8 square root 3. Because point C bisects the remaining arc, its central angle is exactly cut in half, placing it at 8 square root 3. Notice how they share the exact same height, meaning the line segment CD runs perfectly horizontal. Finally, using the midpoint formula between the origin side and point D, we locate our target point E at -12, 4 square root 3. With all our coordinates locked in, the final step is simply applying the distance formula between C and E. When we subtract the coordinates and square the differences, the horizontal components give us 400, and the vertical components give us 48. Adding those together gives us the square root of 448. By factoring out the largest perfect square, 64, the entire problem collapses into a beautifully clean, exact final answer. 8 square root 7 units. It is a fantastic reminder of how a few simple geometric constraints can perfectly dictate an exact distance across a circle. Thank you.